Hello, everyone. One of my friends asked me to mesh something in snappyHexMeshDict. So I asked him to give me his STL file so I can mesh it in snappyHexMesh. Just as a reminder, it's a tutorial, so we are going to face some errors during the meshing process. So I cut I cut the video and start to do it again so you can see what's the final result. And we are going step by step toward to the end. As you see, this is, I think it's an injector. We are going to put it in a domain. So right now we don't have any problem with this one. As you see here, we have, it's a very small mesh. It's a very small feature like this, as you see here. So I'm going to make this file, to mesh this file as a snappy hex mesh. So we see the geometry and we are going to mesh it. I have already have the mesh file. So I have already the background mesh, but I'm going to let the background mesh. So start everything from scratch, so we can have a good knowledge about this one. So I'm going to just remove the polymesh file. Okay, I just removed the polymesh file. And here, as we know, for the snappyHexMesh tool, we need to have a background mesh. Here, for the background mesh, if we go to the constant, sorry, we have to go to the system. Just here, if you see, we have a BlockMesh. I have this background BlockMesh. As you see, I have my vertices and I have my blocks. So I'm going to just do a very quick BlockMesh so we can have the background mesh. We do the BlockMesh here. Okay. We just created the BlockMesh, as you see here. Okay. Here, it's the meshed block that we have here. As you see here, just I want to show you the size of the domain, so we understand what's the sizes are. This one. Okay, data access grid. Okay, this is, as you see, it's about 900 millimeter or 90 centimeter. And I'm just going to make it plain so you can see the inside of the geometry and the mesh inside of it. As you see here, yeah, this is the mesh that is created by the BlockMesh. So I'm just going to visualize it better. This is the original background mesh. So we are going to add our geometry and mesh it again. It will be a procedure with try and error. So maybe in some places I just cut the video and started again. So this is the file, the step file 11 STL. I have previously meshed another thing, which the name is here in constant. So this here, tri-surfaces. Is in this tri-surfaces, as you see, I have these one, IRE2, and bubble sparger IRE2. So I'm going to just remove all of them. I don't need any of them. So I just remove this one. This is from my old snappyHexMesh experiment. So here, I'm going to step file this one. I just copy this one to my constant. try surfaces, and here I'm going to paste it here. So I paste it here. We have this one we need to have, and I already showed you in my another YouTube video how to detach all of the surfaces. So we can have the detached surfaces, or the other name, the exploded surfaces, using the space claim. This is the easiest way to do that. So again, I am going to my constant. In the constant, as you see, I just again remove the polymesh file. So we start everything from the scratch. Okay, we are going to face problems, but we are going to solve them by one by one. So we can have a good grab from the snappyHexMesh tool. As you see here, okay, I have already generated a file. The name is the runCaseFromScratch. Just a quick one. It does the BlockMesh. It does the surface feature. Then snappyHexMesh override. Up to here, everything is finished. But since we have created everything in millimeter for the OpenFOAM usage application, we need to transform everything to the meter. So we need to transform points, everything from millimeter to meter. Then we need to renumber mesh override. And these are for the decompose power and the running. These are for the running purpose. We are not going to deal with these ones. So I'm just going to start from these ones one by one. We can run this one together, but I'm going to do it one by one so you can see what's the differences in every command. Okay. Just again from the scratch, BlockMesh. I did the BlockMesh, so we create the background tool, background mesh. Then surface, the other one, surface feature. Okay, I did this one, and it already gives me an error here. It gives me error that we can't find the IRE2 file from here. The reason that I have changed everything, so everything, the name must be IRE2. Every file that I enter to the this one, I change the name to IRE2, so that is easier for me. If you go to system and here on system surfaceFeaturesDict, you can see here the name of the file is IRE2. Either I should change this one or I should change my its STL file. So that's easier, more handier for me. Change the STL file. So I'm going to my STL file, which exists here in the constant. Try surfaces. And as you see here, I just change the name of the step file here to IRE2.stl. And by the way, IRE in Turkish means separated, IRE to STL. So I just change it. So I just go to repeat the surface features, surface features. Okay, this one has finished. So we have generated xmesh. Just to show you what's happened there. Oh, sorry. Just to show you what's exactly happened there. I'm going to constant again. In the constant, we have to go to try surfaces. And as you see here, IRE to STL, and we have the IRE2.emesh. We have generated this one. So, okay, I'm just going to do the snappyHexMesh, and I got the errors and solve them one by one. Okay, I just do the snappyHexMesh dash override. Yeah. I'm waiting to give me errors so I can go and do them one by one. Okay. If it doesn't give me error, in that case, I am going to explain it to you one by one. What's the features in snappyHexMesh tool, and I'm going to give you the exact my snappyHexMeshDict, so you can use my own snappyHexMeshDict in your cases, so you can repeat the procedure exactly like me. So just right now, it will take 5 minutes to almost 5 minutes to do this. I'm going to stop recording, and then again we come back to you after this one finished. Yeah, I just stop record. Hello again. This one actually finished without any error, so I'm just going to explain one by one what's happened and what is the exact things happened here. So we will get errors, but let's explain it. The first thing, the snappyHexMeshDict itself, it's inside the system. If you see this one, snappyHexMeshDict, this is the one. We should have this one, and I'm going to give you this snappyHexMeshDict in my YouTube channel, so you can refer to that one and use it. Also, the other important thing here in try surfaces in constant, we should put our STL file here, try surfaces, so we can use the surface features to make it as an emesh. So I'm 99% sure, almost 100% sure, I can't visualize this one. The reason that the boundary conditions is different, but I'm going to try this one to see what's happened exactly. Okay, this one will give me error. Okay, and the error is that he cannot find this patch. Exactly, he cannot find this patch, and in the inside the P file, P boundary condition field, he cannot find this one. So we have to either change the name of the boundary conditions in the P file, in the initial condition, or we should change the name of the STL file. Which one on the name of the names in the STL file. Easier thing for us is to change the name of the STL file, since changing the name of the initial condition is not something doable every time. So the STL file is easier to change. Just I'm going to show you this STL file thing here, the names. As you see here, this one, since we have imported from the space claim, it has some features like this, which is it is not a good naming, so we need to change this one. We have this one everywhere. We search for solid, you can see another name exactly here. Okay, another name here. Okay, and another name here. So, and also I have put 4 injectors. I'm going to search for injects. Okay, as you see, this is solid inject this one. The other one, solid inject this one. And yeah, we have 4 of them. Another one, this one. So what I'm going to do, instead of changing the boundary condition, I'm going to change my STL file. Okay, since we go to the 0, to the pressure file, as you see here. In the pressure file, we have outlet, valve corners, spargers, sparger this one, sparger this one, and sparger this one. We have these names 1, 2, 3, 4, 5, 6. So these ones, the outlet and the valve corners, comes from the BlockMeshDict, But the rest of these ones, 1, 2, 3, 4, these names comes from the STL file. So in my STL file, just I want to visualize it. I'm not going to run it. Just to visualization, I have to change all the names to these files so we can visualize it. Just these 4 names here. So I'm just going to close this one. Just we want to see the mesh. Our purpose is not to run the simulation. For the simulation, yes, you have to do everything correctly, but right now I don't care about the correctness in the simulation. So here I'm going to again the constant. In constant, I'm going to try surface. And in try surface, this one, the IRE2STL, which is exactly the copy of this step file, STP file STL. I just renamed that one. I'm just going to do this IRE2STL again and change the names here according. Okay, so everything that is vol like this, everything is vol. So the time consuming, I'm not sure to just make the video off and do it again and show the final result, or do it one by one. I'm going to just do few of them together. Then after that, you can do it yourself. So I forgot something in the system. Again, in the BlockMesh, I'm sure almost all of you are familiar with BlockMesh. I open it in the Genie so you can have better visualization. In here, the boundaries, the outlet, and the wall corners, these two are which are in the P file, pressure file, outlet and wall corners. These names comes from the BlockMeshDict, the background mesh, outlet and wall corners. But the rest, as you see here, the outlet, wall corners, sparger, this one, sparger, this is sparger, this one, and this one. These ones comes from the STL file. So here, I just move this one here. Just I said that my purpose is to just visualize it, nothing else. Visualize the mesh. I just copy the sparger stay out. So everywhere that I have to inject, I search for that, and I replace this name with the desired name. I did this one again, another injector. I'm just repeating. This purpose is just visualization of the mesh. We cannot run this one since the boundaries is incorrect. So I'm going to do it again, this one. Okay, I think we have another injector. Okay. Okay, we don't have an injector. And for this one, sparger wall XDA out. I just put this name for that. And for the rest, I just put the name of the wall. I just go to the beginning of the file. Okay. This wall here, just omit the rest. Here, up to here, I just put the wall. It must be this name, one of these names. It can't be just wall. So I put the name, this name for that. Actually, I did a mistake, but it doesn't matter. I just put this name for that. Okay. Okay. And wherever we have solid, we have to change this name to this one. So I'm searching for solid one by one here, as you see here. I change this one by this one. We have, I think, 10 of them. I think so. Just a sec. Okay, they already, this one's changed. Okay. Okay, just I have to stop the recording. So I have just 10 minutes. So just sec solid. I change the name here. And again, I changed, oh, this is Sparger. It's the vol 6. I changed the name here. I changed the name here again. Change the vol 4. So vol 3. Vol 2. And this one is not solid. This one. I think we are finished. I'm going to visualize it again. But first we need to do the snappyHexMesh again. So yeah, we can have the new names under this one. So here, again, I am going to repeat the same thing, and I'm going to do, yeah, I'm going to just delete the, I'm just going to delete the file in the polymesh again. So we start from scratch. Okay, here, BlockMesh is done. Again, after BlockMesh, I'm going to surface features. Okay, this one changed the names. This one's finished. So at the end, I'm going to do snappyHexMeshDict override. I'm going to stop the recording. So the snappy does its job. Okay, it is, yeah, without any error, it's going to do it. Okay, just I'm going to stop it. Okay. We will see you in the third video. Thanks. Just okay. Stop. Okay. The snappyHexMesh is finished. Just we want to go to visualize it. What's the mesh and what's exactly the mesh looks like. And as you see, it gives error and it says that we cannot find patch entry for Sparger wall injector SY. And he said that in the P, it does not exist. And as we remember, there is no such Sparger wall injectors Y. If we open it, the P file, the only thing that we have is Sparger, not Sparger. So we go again. We see what's the problem. Actually, I understand what's the problem. Let's explain it to you. Here in the snappyHexMesh tool, which I am going to explain it at the end. If you see the geometry, which I have given IRE2STL, which tries surface mesh, here I have to connect Sparger. So at the beginning of every surface name, it adds the Sparger name underline. So we have, it is double than Sparger name. It is multiple time it writes it. So it's better to go to the system. Constant. In constant, we have to go to the tri-surfaces. In tri-surfaces, we open the IRE2STL here and here. Again, you see that I have mistakenly add this one. So I just choose this one, Control F and Control, okay, I have to replace it, just, okay, Let's I just Control R, I think. Let's just search here, replace. And replace instead of the Sparger underline. Okay. Here, replace with nothing in document. So if, as you see, I have omit the double Sparger in all of the document. So where is this the Sparger underline occurs? Okay, like this. Just omit the Sparger, so we can have the mesh itself. We can have the name itself, not the Sparger repeating here. So again, we go back here. Okay, we have to go to constant again. Inside the constant, we remove the polymesh. Again, we need to do the BlockMesh. So if you want to learn about the BlockMesh, you can search in the web. There are lots of documents about the BlockMesh. That's the easy part. So I'm not going to explain that one. Especially the ICO foam example, cavity, you can search that one. And here, let's go to inside the run from scratch. Okay, VI run case from scratch. As you do the second one, surface features. We have to run surface features. Okay, we did that. This time, since it takes very small time, I'm going to do the snappyHexMesh just in front of you. It takes 2-3 minutes, so we can wait until that time. snappyHexMesh dash override. Okay. Okay, hopefully this will be good and we can make it work. And last thing, I'm going to explain you the BlockMesh and how to refine the mesh. Actually, this file has refined the mesh in some cases. In one point, I'm going to change that one, how you can, after meshing the STL file around the STL file or outside the STL file, how you are going to do that, how you are going to refine. For example, you have the airfoil, you are going to mesh the airfoil, but you want to see the wake behind the airfoil, so you need to refine the mesh behind the airfoil. There's the searchable block or searchable box, searchable cylinder, so you are going to search for that. You write the exact locations, and after that you are going to refine it as you want. Actually, I have refined here something. When I visualize the mesh, I will show you what is refined exactly, and I can change it that very easily. I'm going to show that one to you. I'm going to explain a little bit about snappyHexMeshDict. Yeah, so you can have a good idea how to change it. Okay, it must be finished in a matter of seconds. Let's wait for it. Okay, it's finished. I'm going to, with the paraform, I just open it, and hopefully this time it doesn't give any error. Okay, there is no error. Let's first see the background mesh and what's inside. Okay, surface with edges. Okay, and here, as you see here, let's say omit the omit crinklet and this one. Okay. This is the mesh that I also remove the plane. Yeah. Okay. As you see here, okay, this is what we have here, what we have put here exactly. And you see, since it is very small, we have to refine mesh few times to capture the mesh. As you see here, it's a very, very small thing compared to the whole mesh. So we need to refine it. I increase the refinement level there. I just do another slice here. Okay. And yeah, and do this and do this again. And yeah, this one. Okay. Let's say I'm at this one. Do this here. Okay. This one. And here. You have to again do the same thing, surface with edges. Here you are going to show plane. I'm at the wrinkle and angular. Okay, as you see here, the original thing that we had. Okay. Is this one. This is the one that the mesh happened here. And as you see, it's very, very narrow in some places. So it has to make it very, very small. Make the mesh smaller and smaller. I am going to open STL file, original STL file, so we can see what does it look like exactly if it open it. Yeah, you can see the original STL file here. Also, by mistake, the STL file is a little bit in the negative side, so we don't have the mesh of that one. So before going to anything, doing anything else, make sure that your STL file is in a correct location. If you see here, it's my friend geometry. So he just make the STL file in a negative. I don't know how to change it. So I always make the STL file in correct position. If you see, it is in a negative direction. So if it is in negative direction, go make the BlockMesh in that negative direction too. For example, 2-3 centimeters down that one, so you can mesh it exactly. But here, it's yeah, it's a, let's say I'm at this one. Yeah, and you see the main problem happens exactly here. Exactly, not the large surface. The main problem happens exactly here. This one is very small, very, very small. So, yeah, as you see here, it is super small, this one, compared to the rest. We can do two different things to visualize this one better. I'm going to explain it, but maybe I don't have the time to do it, but you know how to run it, how to do the operations. Just I am going to show you how you can do it. Let's say I'm at everything again. I start from here. I open the paraform. Okay, we know the everything exactly what is there. So just apply it. Okay, here, if we visualize this one, again, surface with edges, you see just it is refined here, not anywhere else, not anywhere else. So we need to refine exactly, find the location and refine it exactly there. So let's we go to the system And inside this system, I'm going to explain you the snappyHexMesh tool a little bit. Okay, I have this castellated mesh, snap, and add layers. This add layers is just for the boundary condition, not boundary condition, the boundary layer. If you want to go smaller and smaller and add layers, you need to do this. But castellated mesh, it is using the STL file and it is generating the mesh around it, snap the mesh to the geometry file. So there are three things, three steps. Always, for my cases, always these are true, but I never use the boundary layer using the snappy. You can use it, but I don't need it at that one. Here you have the geometry. You need to name after that file. My name is IRE2STL, and the beginning name is Sparger. So this one is Sparger underline name of the surface. This castellated mesh control. You need to define the maximum number of the cells. I put 5,000, I think 5 million. I believe it is 5 million. Yeah, 5 million. Max global cells. How many global cells? This is local when you are refining. This is global. All of them is just 8 million. You can put it's estimate what mesh do you want and put a number close to that one. Mean refinement 5 times. Max load and plus you can read the details here. I never changed this one. It is 0.1 and number of the cells between is 3. And features, I put the feature level, this one level 2. You can go up to 6. It is the mesh refinement, how much refinement you want to do close to the STL file, close to the geometry. In my case, this is my friend's case. In my case, I always with 2, I get very good results. You can easily change it to the 5. You can change to the 8. I never see more than 6. So go maximum at 6. But I'm going to change it to the 5. So I show you something else in the domain. Exactly what's happened when you 5. And you see the refinement features. We want Sparger, and this is the important thing. After we do this one, level 5, we need to define, okay, if you are trying to do the STL file, how much level you want. Since I put here 2 previously, I put 2 and 2. It means that just do it twice, not more than twice. If you can put 2 up to, for example, 6, it means that do it 2 at minimum and maximum at 6. So you can have, actually this one must be smaller than this one, I think. So I can put maximum 5. So it is going to refine the mesh twice, 3 times, 4 times, and maximum 5 times compared to the initial mesh, background mesh. So at least twice, maximum 5 times. If you want a specific one, just put, for example, 5, 5. So every time it does it 5, 5. 5 times mesh, make the mesh smaller compared to the background mesh. This one I put 2, 5. Okay. This one result sharp angle. This is I put 3. Refinement region. I didn't put anything here, refinement region here, but I'm going to import it here and show to you what is this one just in a sec. Location in mesh. You need to find the location in mesh which you want to locate. Whenever you put a STL file inside the geometry, you have 2 different regions. One is the solid region, one is the fluid region. It says that where you have the fluid region, you have to define the fluid region. So it starts to mesh the fluid region. You cannot put the point in the solid region. If you put it that in the solid region, it just knows that that one is also fluid and mesh that one. So you need to, in your domain, you just find where is the location of the fluid, and you just put the point So it must be outside of the STL file. That one. Allow free standing features. Okay, this one I'm not sure exactly what, but you can read the details, but I'm not sure what is that one. These ones I never change it. So snap controls, don't change this one also. Just use it as it is. And the last one, add layers. This is for the boundary layer. Again, I never use this one, but it's very easy. It's just a try and error. Go and see what is this one's, what is aspect ratio. It is 1. So I believe in the when you put the aspect ratio 1, it is the same as the close one. If you put, for example, expansion ratio, I just put it 5, and the other time put it just 0.2. So you see what's happened, what's the difference. So you understand one by one what's these parameters. I never do the boundary layer simulation, so I don't use it. That's it. And yeah, at the end, we don't, everything is finished, so we don't need to just go and do everything what you want here. I'm just going to add this one. You see that I put the 2 and 5 here and 5 here. Just I'm going to run and show you what is this one, and then going to add the refinement. This one I'm going to add this part, refinement region, so you can see what is refinement region exactly. So these two. So whenever you have STL file, you have 2 things to do. First, you can make the levels higher and higher, so you can have a refined mesh there. The other things that you can do it refined by the refinement region, like this, close to that place. So I'm going to just show you just one thing and just close it and do it again. Okay, this one. It's just, there is no need to repeat anything. I just do the snappy. I have the BlockMesh, I have the everything. Let's just do it again from the beginning here. That's, I don't mess the things. RMPolyMesh. Okay, I just start with the BlockMesh. As you see, the BlockMesh is done. Then surface features again. Actually, we don't need to do that because we have done it, but let's do it again. This is done. And snappy. This time, the snappy will take lots of time. So I'm just going to show you what's the level to this here exactly. I change the level to 5. So it must repeat every step up to 5. This we see, it starts from the 1 to 2, 1, 2, 3. It is 2 times refinement here. This time 2 times refinement. The other one here, I think 3 times refinement. It's go 4 times refinement. So at the end, it goes 5 times refinement here. And it will take a very long time to do this. As you see, 5 times refinement. I put maximum 5 times refinement of the snappyHexMesh tool. So it does one step, then it start again from the beginning and do it again 5 times. It is close to that surface, so it is repeating the 5 times. I'm not going to make this video. I'm just going to stop it, and again I'm just going to have to refine the locally, have to refine it, and I think that will be the end of the video. Okay, just thanks. Okay, just I'm going to stop the recording. Cool. Okay, the snappyHexMesh is finished with 5 levels, so I'm just going to show you what's the result for the 5 levels of refinement. So if you remember the last one, that one we barely just capture the main thing, the injector, but this time it is much better. The result is much better. So you need to play with that so to get the better results. Just okay. Here. Oh. Okay. let's just zoom in. Okay. Okay, this time, yeah. If you see this one, this time is captured much better. If you see, except the tip of the injector, which is here, we almost captured everything. So I'm going to visualize the mesh here. What will mesh look like? I'm going to make the info. If you see, this is a much better mesh, and you see at least, yeah, let's count it. This is the original mesh, 1, 2, okay. This original mesh, 1, 2, 3, 4, 5. And if you see these ones, that this one is that from mesh level 1, 0 to mesh level 1. Mesh level 0, transition to mesh level 1, transition to mesh level 2, 3, 4, and 5. Even we can go smaller than this one in order to capture the tip of the injector. We should, my friend actually should do that. I just show you how to do this. Yeah, this is the mesh. Even my BlockMesh is not correct for this simulation. I just use my former BlockMesh. So last thing I am going to teach to you is the surface feature, which I have in the here. I'm going to my old snappyHexMesh. Okay. This is my old snappyHexMesh, and I have refined the mesh here a little bit, if I remember everything correctly. Okay, no, this one is also, they don't have the refinement region. Just give me a sec. So I find the case with the refinement region. So I just copied that one, and we can have the refinement region in our case. Just give me a sec. Okay, Genie snappyHexMeshDict. Okay, this one has it, I'm almost sure. So I'm just going to remove the last one. Okay, this one. Okay. Here, it's in the geometry. I just put the sparger. After sparger, I have the cylinder refined one. It's a name. So it doesn't matter. So I just copied this one. Exactly from here to my here. Okay. To my geometry. Okay. Here, I put this one exactly here. Cylinder refined one. I just want to change the name. So I put my name, Farzad. Okay. The point, it is search for a cylinder. So point 1, it is the location of the center, and at the bottom, and location of the center at the top. And radius, what's the radius of the cylinder? So this is this one. Let's go and look at my previous one. It is the refined one. So what is the refined one again? So we search for this one. Where I did. This is the name of the feature I have generated there. So refined one. Okay, refinement region. Inside the resolve feature angle. Here, I just refinement region. I just choose this one. As you see, Control C. Go to the snappyHexMesh, my original. I have that angle one. I have to search for the angle, where the angle is located exactly in the file. Okay, here. In the refinement region, I just at this part, refinement region, and if you remember, I changed the name to Farzad. I add my name with the capital in my name. Okay. I just put here Farzad. exactly like this. And I just save this one. I think this will do our job. But before going, since it takes lots of time to level 5 meshing, I just make it level 2 meshing. And again, here I do them level 2 and 2, just do it twice. I just save it. Just that's it. I'm going to the main solver that I have. Z9 tutorial, snappy tutorial. So here, Z9 tutorial. Here, I'm just going to again to constant Genie, not Genie, remove the polymesh. I removed it. Then again, I'm going to, this time I'm going to run the batch file, run case from scratch. Okay, this one, do the BlockMesh. This one, feature, extracted. This time we do the snappyHexMesh and override. And if you remember, everything is millimeter. So we need to change the transform point from the millimeter to meter. And we do every time that we do a new brand new mesh, we need to do the renumber mesh dash override. But here, I don't want to do the compose part. I don't need that one. And I think I should put the $sign. Let's say the $sign here. I believe so. Maybe I'm wrong. So I just remove this part. I don't need this part. I just remove it. Renumber mesh dash override. So instead of doing those one by one, I just make a bash file. So it does everything for me from the scratch, run case from scratch. And it's a level 2, so it will be fast. Okay. Just we wait for 1 minute or 90 seconds. It will do the job for us. Okay. And okay, just here in the system file, we have 3 different folders: 0, constant, and system. In the system file, system folder, you have the snappyHexMeshDict and also you have the surfaceFeaturesDict, which I will show you it in a matter of seconds. Then, as you see, it is I do it level 2, so it is just do it 3 times: original mesh, second mesh, and third mesh. Yeah, just twice. Original mesh and other 2. Okay, I was saying that in the system folder, folder, you have the snappyHexMeshDict and you have the surfaceFeaturesDict, and inside the constant, which you need to put the STL file there. It is the you have the try surface folder, which you should put your folder there, your STL file there, so it can generate the emesh file for you. Okay, we should just must finish it. It's almost finished. Before going to show this file too, I'm going to show you the files in the system and also the constant, so you can see what's inside. Yeah. Just give me a sec. Okay, let's just. Okay. Takes a little long, but let's wait since it must be finished. Yeah. Okay. 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 Must almost finish it. If it takes too much time, I will omit this part from the video. Okay, that's finished. That's finished. The snappy finished exactly here. It's just this one is just the info file, just the topo set. It doesn't do anything. After that, we have the renumber mesh, as I told you. And again, everything is done, finished. And yeah, I just go to the run case from scratch. It does the BlockMesh for us. It does the surface feature. It does the snappyHexMesh override. It just echo the topo set. It transform points, so it makes it at a meter, not a millimeter. And it renumber mesh and overwrite it, which we must do every time that we are doing a mesh for the first time. So I'm just going to show the files here, system. Inside the system, we have snappyHexMeshDict and surfaceFeaturesDict, which you should put it exactly here. I'm going to give you these two files. Again, in the constant file folder, you have the tri-surface, which you should put your own STL file here. So we can create this ire2.emesh from that using the surface features. I'm going to visualize the remaining for you. Visualize our case for you. It's just, if you remember, we just do the mesh level 2, not 5. So this time we should have a bad mesh close to our STL file. So surface with edges. Okay, I'm just going to not show the plane. We don't need that one. I'm just going to crinkle and triangulate. Okay, let's go first close to our STL file, so you can see what's the difference. If you see, we have done just the level 2 meshing, so just twice it reduced the mesh size. If you see, wherever we have this triangle, this is the transition from the BlockMesh original background to the level 1, and transition again, level 2, just that. And it's a very bad meshing for our purpose. My friend must go even with a 6, not even go to 7 or 8, something that it gives him the correct answer. And the important thing, I said that we have added the searchable cylinder. This is the searchable cylinder here. I'm just going to show you, is it cylinder or not? So here, I'm going to cut it from the middle plane. Exactly here. And I just visualize the mesh. So you can see it's exactly a cylinder here. In many cases, for example, airfoil or other stuff that you want to see the wakes exactly, you should do something like this. It's, you see, this is the, which I have put this one here. Wherever you want, you can find put this your searchable cylinder or searchable block there, wherever you want. So this is done correctly without any problem. Yeah, just I'm going to emphasize on one thing and finish the video. Yeah, emphasize on the snappyHexMesh, this level of this refinement. Just if you like the video, like it, or put a comment or subscribe the channel or share it with your friends. I think it's a very complete guide to how to use the snappyHexMesh tool in the open form. I think it's a very complete tutorial, very basic tutorial. So you can use it as a reference. I'm going to inside this system and just going to go to Genie. I'm not going to repeat this one. I just want to show you how to do this. If you go to the, okay, I put the name RefineFeaturesDict, if you remember. RefineFeaturesDict. This is the geometry that I have made. But I just go to search for that again. Here, refinement region. Mode inside level 1, which it said from the background mesh, just one time reduce it. Level 1, what is that? Level 1? It was an X direction cut into half, in Y direction cut into half, in Z direction cut into half. So 8 times smaller than the original one. If you see the, put the level 2, you can put to level 3, level 4. This one, you can do whatever you want. Yeah, to refine the mesh. This is the last thing I just want to emphasize. I'm not going to repeat it again. You can just make it 3, 4 and do it again yourself and see the result. I think I covered everything. And just the last thing before finishing the video, I'm just going to show you again that refinement region so you can understand it much better. Yeah, just give me a sec to load it. It's loaded. So here, surface with edges. I just crinkle it. Crinkle it, this time. And just going to here. If you see in X direction, it is divided here exactly. How can I? Okay, here where I put the pointer, divided by 2. In Y direction, also divided by 2. In Z direction, it was also divided by 2. So divided by 8 every corner. So if you see, for example, okay, I should omit the show plane so it doesn't encounter with us. Okay, if I go here, it is exactly show in X direction and in Y direction and X direction. This block, both places divided by 2, so it is 4 times smaller than its closest cell, this one, compared to this one. Yeah, as you see, the BlockMesh using the refined one, divided by 4 in 2 dimension and divided by 8 in 3 dimension. Thank you very much for watching. I hope that you enjoyed the video and snappyHexMesh tool. Yeah, thank you very much and see you again in my channel. Thank you very much.